SmartGeo can be utilized also for running MODFLOW simulations, flow simulations. MODFLOW is a code developed by USGS for running flow simulations in the saturated zone. So on the website, the USGS website, you can find the guide and with all the parameters necessary to run a simulation. So SmartGeo utilizes MODFLOW 2005 for reproducing the aquifer behavior. For instance, if we open the second tutorial, here you can find how you can set the boundary conditions to your domain. In particular, you can do this by using polylines or points. By using the boundary layer, you can assign Neumann or the Richelieu boundary condition to polylines. We can decide to assign a boundary condition to a point. In this case, we have to select wells, and we have to draw points where we know exactly the value of the hydraulic head or the flux. But we can also decide to define rivers. So with the river layer, we can assign to the polyline the property of river, the river conductance, which is proportional to the riverbed hydraulic conductivity, and we can set to the nodes of the polyline the values of the stage, the river stage, and of the river bottom for the correspondent time interval. So once you have defined all your boundary conditions, all your domain, and the grid, above all the grid, you can run MODFLOW simulations. So it's really important to note that with the scenarios button, we can run the same MODFLOW simulations, but for different scenarios which correspond to different conditions for your aquifer. So we save the project and we run, and as you can see, we have already set here two scenarios. Here we need to define the same parameters already defined for the hydrogen simulations. So minus 2.3, 0.8, 500, 200. We don't need to fill out these parameters. We for Monte Carlo simulations, we say 5, the seed number, the shape of the covariance function, and we need to set also the MODFLOW parameters. So the constant value for the initial hydraulic head, the second scenario, the top elevation of our aquifer is set to 2010 meters and 170 meters. The type of the aquifer is convertible, which means that can be confined or unconfined. We save the settings in the right folder, and we run. See that the MODFLOW simulation is run for 5 times because we run 5 Monte Carlo simulations. So this means that SmartGeo, for each field, hydraulic conductivity field generated with hydrogen, runs a MODFLOW simulations, a flow simulations. Okay, so we can load the results. In this case, the results are represented by the hydraulic conductivity and the hydraulic parameter maps and the hydraulic head simulated for the first and the second scenarios, which were called test 1 and test 2. So if we decide to open the hydraulic head simulated by MODFLOW, for the first Monte Carlo simulations and for the first scenario. Here we can select which time steps we want to visualize. Since the MODFLOW simulations, if you remember, were divided into 10 time steps, here we need to select the color scale and OK. So now we can see that the hydraulic head simulated is represented in this map. So here where we had the well, you can see that the hydraulic head is lower than the neighbor area. You can export the results to an external scatter file. You can see if we load the same the results of the same scenario but for a different Monte Carlo simulations, for instance for the fourth Monte Carlo simulation, you can see that there are differences because they are obtained with MODFLOW but using two different Monte Carlo simulations generated by hydrogen. Since this well is also an observing well, we can visualize the hydraulic head behavior in correspondence of this point simulated by MODFLOW. It is only necessary to click on the Heads button and to select the number of Monte Carlo simulation that we want to visualize and select the name of the scenario that we want to obtain. In this case, we selected test first in correspondence of the first well. And as you can see, here you can find the simulated hydraulic head in correspondence of the first well. And this is the comparison with measured data. But in this case, we are not running optimization, so we are not trying to fit this curve with this curve. So it can be acceptable that we have a difference between the simulated and the measured values. We can also save this image, we can show the values, so we can do and we can query the graph. Okay, thank you, bye.